So we're going to make a stress strain curve for the concrete using these papers here, and that's equation to make stress strain relationship for concrete, basically confined by the steel tubes. Like if you have a concrete inside and the steel tubes outside, what would be the stress strain curves that can goes into the Abacus software. So there are equations from 1 to equation number 6 that we're going to use it. So let's get the equation number this one first, and that's equations. We're gonna go to our Excel file, which is basically putting it here. Okay, so that is the equation number 1. Now let's get these ones here. So we can have a let's say strain value, and we have a stress value, right? So let's say 0 and 0 is the starting point. Now to start with, we can just give you the inputs. So what inputs do we need? Let's say the inputs that we need is FC dash, and the FC dash that we're going to get is, let's say for examples, 50 megapascals, let's say megapascals. And then we have a let's say width of which is 150 millimeters, let's say. And then that is also the depth as well, D, or you can make it 2 separates, that is no issue. Let's make it 2 separates, B and D. Let's say we will have a square, otherwise you can use different rectangular like a depth as well. And let's say thickness would be around let me think, 150 divided by 3 give you 50, so D on T. So let's say 3 millimeters is a thickness. Now once you got these ones, we can also need the steel tube yield strength, steel tubes yield strength. Let's say we can use it 350 megapascal steel strength yield tubes. Now so that's all good. So this is the first one. If I just go and get our equations, which is these figures. So let me get these figures here, copy, and then we can just get these ones here. So basically from this O to A, we can use these equations. Now in that equations we need some values, which is gamma, and we need EC. EC is, this is epsilon C is basically strain, and this gamma value that we need for this one, so is lambda we need it. So let's calculate these values, and we before that ones we can just calculate these ones. Let me get these equations as well. So here you go, these equations, and in this equation DC is B minus T or D minus T for rectangular cross sections larger of this one. So we need to take the maximum of this one. So control V. So let's say gamma C, let's do the calculation here. Gamma C, we can have it before gamma C, we can calculate DC. DC is equal to maximum of B minus 2 times T, comma D D minus 2 times T, right? So that's DC, and that is 1.85 equal to 1.85 multiplied by DC to the power of minus 0.135. So that is DC. Make sure that it has a conditions in that one. So the condition is it should be between 0.85 and 1. So if it's less than 0.5, we take it 0.85. is greater than 1, we take it 1, but it is 0.95, so it should be fine. Now after that we can calculate the Young modulus of the concrete. Now the Young modulus of the concrete, the equations that we going to get is this ones. Before that we can get FCC dash. I think FCC dash would be same as this is effective, so there you go, FCC dash. So probably that's FCC dash would be same as our FC dash. It's just the effective concrete compressive strength. I think there should be no any increase of the strength. Okay, FCC dash is your FC dash. So let's figure it out. This one, FCC dash, which is equal to FC dash, this one. So that is done. EC, which is the Young modulus, and the Young modulus that we're going to get is, I think, FCC effective compressive strength of these ones, which is basically gamma C and FC dash. So let me see, equal to multiply by gamma C, right? So that is your effective one. And EC, let's get the equation for these ones. So it will be in our Excel file. Copy, and that's here. So equal to 3320 multiply by this to the power of 0.5 or square root plus 6900 is in megapascal. So that's fine. After these ones, we can have lambda, which is lambda. We're going to get these ones. All right, so this is gamma. Let's do this gamma. Now here you get gamma, and this lambda that we're gonna get is between lambda we're gonna get is EC over ECC dash. Before we do these ones, we need to calculate EC FC dash, ECC dash. We need to calculate ECC dash, which is going to be, here it is ECC dash is 0.02 for less than 28, 0.03 for these ones, and we need to do the interpolation. So we can do the interpolations. So when you have FCC dash, you will get 0.02, and for ECC dash, this is ECC dash, by the way, Control C, Control V, and it would be 0.003 for FCC dash less than 28 megapascals, and FCC dash greater than 82 megapascal. So our FCC dash is here 47, so we need to do the interpolation for that one. So let me get the interpolations for this one. The interpolations that we're gonna get is, let me get the equation for interpolations. So the equations for interpolations that we're going to use is this ones. Let's say this is the interpolation equations. Copy, and that's gonna give us, because we are in this range, so ECC dash is equal to 0.002 plus FCC dash bracket FCC dash minus 28 divided by 54. There you go. So that is in between. That's good. Now we can calculate the lambda, which is this equations here, is equal to EC divided by EC minus FCC dash over ECC dash. So that is a lambda done. What else we needed? I think we got everything that we needed for to use in these equations, which is these ones, and these equations would be valid up to ECC dash, right? So ECC dash is 0.002, right? So that's good. .002, so equal to, let's put this 0.00001, and we need to go to 0023, so that is 0.02324. let's say this value same. Let me make these ones different color, so let's say red. Now to calculate the stress, we can use these equations, equal to FC dash multiply by lambda multiply by bracket EC divided by EC dash divided by lambda. I'm just using these equations, lambda minus 1 plus strain EC epsilon C divided by epsilon C square to the power of lambda. That's it. Yep, so that's all good so far. So that's first. Oops, sorry, what happened here? Okay, we need to lock these ones. Everything's need to be locked, so these ones, let's press F4. This need to be locked, F4, and we just need to lock A8 would be variable, which is the strain here, and others we need to lock. Let's lock these ones. Let's lock these ones. A8 we need to keep it, and others we need to lock, and these ones need to be locked as well. Just press F4, that will going to lock everything. Yep, so that's pretty much it. So we got up to this point stress, and now we can just get second one from our file. From these files here we can get the second here, snipping tool, and let's get this second one here, and for that seconds we need to get this beta C first, so that's we can get it as well. Let's put these ones here, and for that we need to calculate beta C. For that we need to calculate this beta C. Alright, so to calculate this beta C, first we're gonna get it. You can use Excel, if, and all these rules, but at the moment I'm just making it this ones. BS, I think definition for BS would be, BS is larger of B and D, so that is good. So you can have BS is equal to maximum of this one comma this one, so that is 150, that is perfect. And BS on T, BS divided by T, you get BS divided by T, you get 50. Then you have 50, so it's supposed to be here in this range, so beta C would be 0.5. Otherwise you can use these if rules, you know how to, for this one up to here you can just make it into the Excels, the interactive. Otherwise you use these ones and predict these ones. Now that is beta C. After we do this beta C, probably we can use these equations to get from A to B. Now the B value that we're gonna get is 0.05. So let's continue. These ones plus these ones, let's make it these ones green. 0.05, there you go. 0.005, perfect. And those three values that we're gonna get, 0.035. we don't need these ones, we just need FC dash. So in here for FC dash for this range, so we can just put FC dash here, and we're gonna lock it. So that is A to be done. A to be done. Now B to C, that is the equations that we can use, and that is 0.15. So let's continue. Let's make it another color so we know. Equal to this one plus 0.001. okay, 0.6. now we need to go up to 0.15. so there you go, up to 0.15. now for that ones we have these equations equal to beta c multiply by, I'm just using these equations. Okay, let's get these ones done. I'm just using these equations. Beta c, I think we need to lock it. You remember that one's lock it. Lock multiply by fc dash. So this fc dash, and then we're gonna lock it. 4 plus 100 multiply by 0.015 minus strain multiply by fcc dash. Now we need to lock it, by the way, beta c. Anyway, we're gonna talk multiply by fcc dash. So we can lock these cells here, this value 835. we no need to lock it. I think that's it. So there you go, from from A to B, and from C to D there is no any limits, but I think we can just extend this ones a bit up to 0.02, and then we just make it different color. So we have different zones that we can identify, and that would be beta c multiply by fcc dash, and both need to be locked, f4 and f4. so there you go, and that's basically your, so in the Abacus softwares it's gonna ask like this, strain first, so you can just make it trace first, so you can just make it copy and paste the numbers, and here you need the strain value, Control C. There are others, I think researchers, if you look at these ones, you need to convert into true straight strain curves and all that. You can do it by reading the manuals, but here this is the copy that you can use it. Thank you very much.